Okay, today we're going to take a look at the second derivative test. So let's go ahead and begin. Learning goal. Students will be able to understand how to use the second derivative test. Now, this is a little easier than the first derivative test. However, it's kind of limited. So let's see what I'm talking about here. It says, let f be a function such that f prime of c is equal to 0, and the second derivative of f exists on an open interval. So basically, if I have f double prime greater than 0, meaning it's positive, then I have a relative minimum. And the reason for it is this. If you have that, then it's concave up. And so I have a relative min. The next one, if I have f, and it should be double prime, I apologize, it looks like a triple prime kind of snuck in there. So f double prime of c is less than 0, then I have a relative maximum. And what that looks like is this. So that means I'm concave down, so I have a relative maximum. And then finally, last but not least, if I have f double prime is equal to 0, then the test fails. What you have there is this. If you have it double prime is equal to 0, you have something called a point of inflection. And a point of inflection is the point where we change from concave, let's say down, to concave up, or vice versa. So f double prime is equal to 0, and you can see in the pictures down here, and I'll go over it again. Here, before, in the first derivative test, we looked at is f prime basically negative or positive, and here what we're doing is this. We're not really using the first derivative, we're just using the idea of the second derivative. Second derivative greater than 0, meaning positive. I have concave up, so that makes a relative minimum. F double prime here less than 0, that's concave down, that's a relative maximum. And then f double prime of c is equal to 0, that could go from concave up to concave down. So that's this location right here. That's called a point of inflection. Okay, so let's see how the test works. Oh, some vocab. Sorry, I snuck that in. The second derivative, if it's greater than 0, then what does that mean for the first derivative? That means f prime is less than 0, it's equal to 0, and it's greater than 0. And you can draw it like we did in an earlier video. That means I'm going like this. Decreasing from left to right for the function, critical number, increasing from left to right. So concave up. And so what does that mean? That means I'm concave up for f. On the next one, f double prime is less than 0. That means for the first derivative, f prime is greater than 0, equal to 0, and then less than 0. What that looks like is basically this. I'm increasing on the function, critical number, decreasing. And that means that I'm concave down. And then the last one, f double prime is equal to 0. That just means that both your slopes are both positive or negative, and that could be a point of inflection. Okay, so let's review on how to find a critical number so we can use this test. So critical number is y prime is equal to 0. So take the first derivative. You get 6 minus 2x. Set it equal to 0. And then solve. So subtract 6 from both sides. You get negative 6 is equal to negative 2x. Divide by negative 2. And it looks like the critical number is going to be at positive 3. Okay, so let's see how to do it. Alright, so with this test, we do not plug into the first derivative. We do not plug into the first derivative. It's called the second derivative test. And very limited, it just finds us where, is it a maximum, is it a minimum, or could it be a maximum or minimum? It really tells you about concavity, meaning is it concave up or concave down. Anyways, so when you're plugging in, don't get in the rut and plug into the first derivative, you plug into the second. Okay, so let's take the first derivative. Y prime is equal to 0, because I want to find the critical number. So y prime is equal to 6 minus 2x, and then set it equal to 0. Subtract 6 from both sides. You get negative 6 is equal to negative 2x. Divide by a negative 2, x is equal to positive 3. So that's our critical number. And what we do with the critical number is we plug it into the second derivative, if we can. And that will either tell us if it's greater than or less than 0. So let's go ahead and do it. Let's take the second derivative. Y double prime is equal to, okay, this is the first derivative, so derivative of 6 is 0. Derivative of negative 2x is just negative 2. Now, traditionally, we plug in the critical number for x. However, there's no x, so right away we know that this is less than 0. So basically, we have f prime double prime of 3 is less than 0. And so what that means is this. We have concave down. And if it's concave down, I have a relative maximum. So that's pretty easy. Now, it's not always going to be that easy. A lot of times you have to still plug in. So let's see if we can answer some of the information here. What can we say about f? We can say that we have a relative maximum. What can we say about f prime? Well, if it's concave down, we know that f prime of x is basically greater than 0, f prime is equal to 0, and f prime is less than 0. What can we say for f double prime? We can say that f double prime of 3 is equal to, I think we got negative 2, which is less than 0. So we know that it's concave down, basically. So that's it. That's the second derivative test. Let's do one more. This one will take us a little bit more time. Let me grab Mr. Blue. It always gives me luck. Okay, first things first, like in both tests, take the first derivative. So let me use the right notation and set it equal to 0. So f prime of x is equal to 0. I want to find the critical number. So f prime of x is equal to negative 15x to the fourth plus 15x squared. Okay, set it equal to 0. So 0 is equal to negative 15x to the fourth plus 15x to the second. I can factor out here a 15x squared. So let me do that. That gives you negative x squared plus 1. Okay, so if I set them equal to 0, I get 0 is equal to 15x squared, and 0 is equal to negative x squared plus 1. This will give you x equals 0 for a critical number. Subtract by 1. I need a little bit more room, so I'm going to scroll down a little bit. I get negative 1 is equal to negative x squared. Multiply a negative both sides. 1 is equal to x squared. So plus or minus radical 1 is equal to x. So plus or minus 1 is equal to x. Okay, so those are our 3 different critical numbers. We got a lot of critical numbers there. Okay, so let's go ahead and let's take the second derivative. So let me grab Mr. Red. And the first derivative we said was this. And so now we need to find the second derivative to plug in. So second derivative would be f double prime of x is equal to negative 15 times 4 x to the third minus, or excuse me, plus 15 times 2 times x. Okay, so now what we need to do is plug in. So let's plug in x equals 0 first. That gives me f double prime of x is equal to 0. So there the test doesn't work, so you would throw that critical number out. Okay, let's go ahead and let's plug in the next one. F double prime of, let's say, positive 1. This is equal to, okay, so I get negative 15 times 4 times 1 plus 15 times 2. Now notice here that negative 15 times 4 is going to be a pretty small negative number, and 15 times 2 is only 30. So here I'm going to have it negative, so I'm going to say that it's less than 0. So that means if it's negative for the f double prime, that means I'm concave down. So I have a relative max. Okay, let's plug in the last one. Let me grab Mr. Blue. F double prime of negative 1 is equal to, okay, plug in the second derivative. Here you would get a negative 15 times 4, and negative 1 cubed is just still going to be a negative 1, plus 15 times 2 times negative 1. And so here I would get negative 15 times 4 times a negative 1, plus, in this case, a negative 30 if I multiplied it out. So here this is going to be positive, and it's going to be a larger number than this, so I know that it's greater than 0. So what does that mean? If f prime double prime is greater than 0, I have basically concave up, so I have a relative min. Okay, what can we say about f? Well, let's see. At x equals 1, positive 1, I can say for f that basically I have a relative maximum and that it's increasing from left to right equal to 0 and then decreasing, so at least my slope is equal to 0. So here I can just say relative max. For x equals negative 1, I have basically a relative minimum. And what can we say about f prime? Okay, so just to finish this thought, then f prime for a negative 1 would have to be f prime is less than 0, f prime is equal to 0, and f prime is greater than 0. For x equals 1, it would have to be basically the opposite. So f prime is greater than 0, f prime is equal to 0, and f prime is less than 0. If you're like, what is he doing? Well, I'm just looking at the sketch here, and I know my slope is greater than 0, equal to 0, less than 0. So that's how I got this right here. And then for f double prime, what can I say? That it's basically concave down. So concave down for this one, and then for x equals negative 1, I know that it's concave up. Okay, so I know that was a lot. That's why I only gave 2 problems. I would say practice it. Remember, for the second derivative test, find the critical number, take the second derivative, plug that critical number into the second derivative, and see whether or not it's less than 0, greater than 0, or equal to 0. So let's see if we hit our learning goal. Students will be able to understand the second derivative test. I definitely think you're on your way. I'll see you in the next video.